Okay, let's now look at a by 8 floating point transform. If you've seen the by 1 floating point transform, this is going to look very similar. I'm just going to highlight the differences. Essentially, all these include files are the same. First of all, with respect to the by 8 init, this actually has the advantage versus the by 1 init that it will actually do a topology conversion of your sample list by 8. In other words, 8 concatenated lists to a list of 8 interleaved sample points. And remember, the other thing that we need to do during initialization is set the first element, or in this case the first 8 elements, to 0 of the monomial list, and then we copy the samples and interleave them to the monomial list. And then similarly, after the transform, we have a list of interleaved by 8 coefficients, and we copy them to a concatenated list of 8 sets of coef count coefficients. And this probably should have been list by 8, but I didn't put that there. So then the transform itself is very analogous to the by 1 transform, although obviously the sizes are multiplied by 8. And by the way, there's nothing magical about by 8. We could do by 2 or by 91. This is entirely an optimization parameter, and the wider that you compute something, the more memory you're going to use, so the less cache efficiency. On the other hand, you're going to get more parallelism. So there is some optimum there, and that's just an experimental question. So the first thing we do, as in the by 1, we set all the coefficients to 0. We go ahead and we unpack all the binomials as before and compute them. But this time, we take this ratio and we reuse the ratio 8 times. So there is some efficiency gain there in terms of the expensiveness of unpacking. And you'll notice that we use different numerators, different denominators, and ultimately we evict to a different monomial. But these are at sequential memory addresses, as you can see, 6, 7, and so forth. And so that's quite amenable to SIMD conversion in the future. Okay, so as of here, all of our binomials have been computed. And as in the by 1 transform, we're going to skip over whatever monomials we don't need to use. And then we're going to get the next monomial count monomials, and we're going to unpack them. I'm sorry, we're going to process them one at a time, and each one has a different number of aliases. This is just like the by 1 case, except that when we actually process a given alias, that is, multiplying a ratio times a monomial and adding it to a coefficient, we're going to do it by 8. So once again, we're going to pre-compute the ratio, and this time we're going to reuse it for 8 different threads, adding to them one at a time. And of course, again, the addresses are sequential and therefore very SIMD amenable. And that is that.